Welcome back to my channel. Today we will learn how to solve the NMR spectrum. Here are some steps that is involved in solving the NMR spectrum. First of all, we will calculate the number of the peaks, as each different signal or the peak in the NMR spectrum tells us a different kind of the proton atoms. Similarly, in the next step, determine the chemical shift value. Each chemical shift value tells us that our protons, that to which groups our protons is attached, so it is also important. In the third step, we will find the integration value. Integration value tells us that how many protons are present in one peak area in the NMR spectrum. And in the next step, we will deduce our structure from our molecular formula. So here, first of all, as you may see here, first of all, we will find our molecular formula from the mass spectrum. As we are solving the NMR spectrum, so we will only take the molecular formula, that is C6H8O2. So this is our molecular formula. IR spectrum. In the IR spectrum, we determine the functional groups that is present in our structure. Here you may see the peak area 1693 region. It means almost 1700 per centimeter region. This region covers the carbonyl groups, so it may be possible that carbonyl group is present in our structure. C13 NMR spectrum. C13 NMR spectrum is that spectrum which tells us the different kinds of the carbon atoms that are present in our compound or in our given molecular formula. As you may see here, there are two types of the NMR spectrum. Here it is given the depth and the proton decoupled spectrum. The peak in the depth that define the CH and the CH3 groups, it is present in the upward directions, and the CH2 group peaks always present in the downward direction. As you may see here in the depth that this peak is in the downward direction. It means that in your compound or in our compound there is CH2 group is present, and no peak is in the upward direction in the depth. It means that CH and the CH3 groups are not present in our compound. Proton decoupled spectrum. As you may see here, there is only one peak in the proton decoupled spectrum. If you see here, this peak is just in the chemical shift value as present in the depth, so it means that this represents the CH2 groups. Okay, now if you find the chemical shift value, it is present almost in the region of 36 to 38 ppm value, and this ppm value defines the CH2 group. Okay, here you find one more peak, as this peak was absent in the depth. So depth tells us about the different peaks, like the CH2 when the carbon is attached with 2 carbon, CH3 when the carbon is attached with the 3 hydrogen atoms, and the CH when the carbon is attached with the 1 hydrogen. So in the proton decoupled spectrum, it tells us about the carbons that is not attached with any hydrogen. So here if you see that the proton decoupled, two peaks is present, and the depth only one peak is present here. So it means that here is also a carbon that is not attached with any hydrogen. So if you see here, it is present almost in the 210 region, ppm region. So it means it tells you about the carbonyl group that is present in your compound. And this carbonyl group, we also defined that the one type of the carbonyl group may be present in your compound from the IR spectrum. So the information that we get from the IR spectrum are related to the information that we are getting in the C13 NMR spectrum. So it defines that there are two types of the hydrocarbons are present in your compound. Carbon is that which is one carbon is that which is attached to the 2 hydrogen atoms, and the one carbon that is the carbonyl group. Proton NMR spectrum. So here you are seeing only the one peak. As you may see here, only one peak is present. It means only one kind of the hydrogens are present in your chemical formula, and your chemical formula was C6H8O2. So 8 hydrogens are present here. This is the integration value. Also it means that in this peak area 8 hydrogens are present here. So single peak tells us that only one kind of the hydrogens are present. Integration value tells us that 8 hydrogens are present in this peak. It means 8 hydrogens are present, and it is also defined from your molecular formula. And now it's time for chemical shift value. As you may see here, the chemical shift value is almost 2.7 ppm value. This ppm value tells us that your hydrogens may be attached with the carbon that is present in the vicinity of the carbonyl group. So if you see here that first of all the CH2 groups are present, and the second was the carbonyl groups are present, and the chemical shift value also tells you that your hydrogen is present in the vicinity of the carbonyl group. So it means you will find the structure that has the two types of the carbons, one type of the hydrogen and the carbonyl group also in your compound, as you may see here. So 8 hydrogens are present. So if the 8 hydrogens are present, it means in your group there are 4 CH2 groups may be present. Why 4 CH2 groups are present? As the hydrogens are of same chemical environment and only the CH2 group is present, it means your hydrogens should be attached with the carbon, and at a time 2 hydrogens should be attached with the carbon. So it means that in your compound 4 CH2 groups are present, and it is confirmed. Okay, and now if you see here 6 carbons were present, and now 4 carbons we have already used to make the CH2 group, so it means now 2 carbons are left. And other type of the carbon that was present in your structure was the carbonyl group, so it means in your structure 2 carbonyl groups are present. Now we will arrange this data just like that only the only the protons that have the same chemical environment should be present in your compound. Okay, if you see here CH2 group is present, it means no CH3 group is present. So to satisfy the this valency of the carbon, it should be in the ring form. As you may see here that 6 carbons are present, so you may make the ring with the 6 carbons. So this is the ring with the 6 carbons, and the 4 CH2 groups should be of the same chemical environment. Okay, if I say that one carbon is attached here, if I say that one carbon is attached here with the oxygen by forming the double bonds, so here now one carbon, one CH2 group, one, two, second, third and fourth. So it means here it should be attached with the other oxygen atom. Now if you see here that this one CH2 group and the 2 CH2 group, these are same chemical environment. Similarly here third and the 4 CH2 group, if you just give this some attention to this structure, you will find that all the 4 CH2 group have the same chemical environment, and these are present in the vicinity of the carbonyl group. So all the hydrogens that is present here will give the chemical shift value in the range of 2.7 ppm value that is present in your proton NMR spectrum. So this is the structure that we have elucidated from the carbon 13 NMR and the proton NMR spectrum. If you like my videos, then please share my videos and subscribe my channel.